Okay, here we go. And today we're still factoring polynomials. We're now factoring trinomials. Okay, so this is factoring trinomials. And what's special about this is it's x squared. There is understood to be a 1 in front. It's just not going to be written x squared plus bx plus c. This is the form that it would be written in. But remember that x is not going to be written, okay? I'm sorry, not the x, the 1 is not going to be written. All right, let's see what that looks like going from the product to the trinomial that we see. So if I have x times x, that's going to give me x squared. X times 5 gives me 5x. 1 times x is 1x. 1 times 5 is 5. And then we combine our like terms. And we end up with the trinomial of x squared plus 6x plus 5. And what we're going to be doing today is going from this back to the product. This is what our answers will look like today. This is what the problems will look like. And this doesn't want to erase. There we go. Okay, so let's work the next one. M times m is m squared. M times 6 is 6m. Negative 4m times m. Negative 4 times m is negative 4m. My brain's working faster than my mouth can talk. Negative 4 times 6 is negative 24. And again, we combine our like terms, which that's going to give me m squared. And notice these two middle terms is what we're going to have to find. And I'm going to teach you how to do that. M squared plus 2m minus 24. All right, so we've got our third example here. K times k is k squared. K times negative 3 is negative 3k. Notice how all these different forms we have. Negative 7 times k is negative 7k. Negative 7 times negative 3 is negative 21. So again, we combine our like terms, and we end up with k squared minus, not 21, you're not multiplying, we're adding, minus 10k minus 21. Okay, so again, our goal is to go from here back to the products. All right. Stepping it up here. Okay, so to factor a trinomial of the form x squared plus bx plus c, remember, it's understood to have a 1 in front of it. This only works when the x squared has a 1 in front of it. You must find two integers that add to equal b, which is this middle term, and multiply to equal c. So add to equal b, multiply to equal c. Okay, so this is the sum, this is the product. All right, so if I'm looking at this example right here, what two integers have a product of 12, because that's this here, and a sum of 8. So that's where I may just start listing, what are my factors? I'm going to come over here and I'm going to say, okay, 12, that can be 1 and 12, 2 and 6, 3 and 4. And they need to be positive because I've got a positive 12. Because I do eventually have to pay attention to my integer rules, and we'll get to those examples. Which ones do I add together and it equals 7? 3 plus 4 equals 7. So therefore my numbers are 3 and 4. So write the two binomials using these integers, then distribute to check. So the rule is you would take it straight to being able to say, okay, these are both positive numbers. So I'm going to have x plus 3 times x plus 4. Now we're going to check this just so I can prove to you that that rule always works. Okay. So x times x gives me x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. And when I simplify my like terms, we end up with x squared plus 7x plus 12. Notice These are the same. They're exactly the same. This is my factored form. Okay, let's get to working some examples. Okay, number one, first thing I've got to do, okay, is I've got to figure out what are my factors of 20, and they've got to add to equal 9. So I'm going to start off just listing 1 and 20, 2 and 10, 4 and 5. Oh, if I add that, that equals 9. So therefore, and only because the coefficient here is a 1, I can do, okay, n plus, and everything's positive, my positive numbers, n plus, and I'm just filling in these spots here because they're both positive. So I've got n plus 4, n plus 5. There's my answer. Next example, jumping down. This is where we throw in some integer rules that we have to pay attention to. This is a negative 18. Okay, so I've got to find the products of negative 18 that add to equal a b of 3. That's a positive 3. Okay, so I start listing my factors of 18. So I've got 1 and 18, 2 and 9, but I've got to remember one of these has got to be negative when we get to this stuff, okay? 3 and 6, okay. I know it's got to be a positive 3, so the bigger numbers have to be positive. The smaller numbers have to be negative because my answer has to be positive. So if I do 6 minus 3, does that give me 3? Yes, so therefore this is my scenario. So I'm now going to have n minus 3 times n plus 6. This is my final factored form. Let's do that one more time. Okay, because we're throwing in these variable, the integer rules in here. So my b is 1 here. My c is negative 6. So I've got to figure out my factors of negative 6 that add to equal 1. Remember, so I'm going to have 1, negative 1 and 6, because remember, I want a positive answer. So the bigger numbers have to be positive. Negative 2 and 3. Ooh, if I add that together, that equals 1. Here's my scenario. And I have g minus 2 times g plus 3. And there's my answer. I'm done. You can always multiply it back to check. Okay. Next example. Go. Flipping this over, and now we're just pulling in more integer rules that we have to pay attention to. We're still doing the exact same process as we go. Okay, looking at number 9. My b is negative 2. My c is negative 3. So I have to start listing my factors, and I've got to realize, okay, for both of them to be negative when I add, well, no, I've got a negative answer. So that means one of them's got to be negative and one of them's got to be positive. But I want my answer to be negative. I want the answer to be negative. So that means the bigger numbers have to be negative. So I'm going to do 1 and negative 3. I don't have to go any further. Those are my actual only factors. And if I add those together, that equals negative 2. That's what I'm looking for. So here's my scenario. And I have a plus 1 times a minus 3. And let's do one more example, okay? All right, so I have b equals negative 2, c equals negative 63. So I've got to think about, well, those are 1 and 63 ain't going to work because if I add those together, it doesn't even get close. So let me think about, oh, 9 and 7, 9 and 7. So I've got negative 7 and a positive 9. But wait a minute, that's not right because that would give me a positive 2. I want a negative 2. This is supposed to be a negative 9 and a positive 7. Because when I add those together, that's going to give me a negative 2. So this is my scenario. So I'm going to have b plus 7 times b minus 9. Okay, moving along. Now I'm going to teach you, we're going to jump to number 15, and I'm going to teach you, what if I don't know the factors to the numbers? I'm going to show you a little trick in the calculator. Okay, so we're still doing the same thing. B is negative 17. C is 72. Now, this, my answer is positive. That means both of my factors have to be negative. Okay, if I don't know what my factors are in the calculator, we can go to the y equals, and I can take C and plug it in and do 72 divided by X. And then I go to my table of values, second table, and it will list all of my factors for me. So I don't necessarily have to write them all down. What I'm looking for right now is the ones that when I add them together, it's going to equal a negative 17. So when I add them together, it equals a negative 17. Negative 8 and negative 9. If I add those two together, that equals a negative 17. And there's my answer. Well, not my answer, my factors that I need. So now I'm going to have y minus 8 times y minus 9. So over here, we're going to put in y equals type C divided by X to find factors. Okay, then you're going to do the mixed practice. So let's jump down here where we have to remember the GCF. Okay, so looking at 23. First things first, I've got to look to see, is there a GCF for number wise? Yeah, there's a 4. So my GCF is 4. Are there any variables? No, there's not a variable all the way through. So my only GCF is 4. So I have to divide everything by 4. So that's going to give me 4 on the outside. You always put the GCF on the outside. Too big or too high, too low, 4. And then I'm going to end up with k squared plus 12 divided by 4 is 3k plus 8 divided by 4, which is 2. Now I have to do what I've been doing with this middle. So I have that the b equals 3 and the c equals 2. So my factors 1 and 2, I add them together and it equals 3. So I have 4 open parentheses k plus 1 close parentheses k plus 2. Here is my final factored form. Last one, guys. 28. Again, you can pause, stop, come ask me questions as you need to re-listen. First things first, I got to find my GCF. Well, when I look at it, I know it's all divisible by 5 and it can't be any bigger because 5 is the smallest number. Now I got to look for my variables. They all have a y, so my GCF is a 5y. So I divide everything by 5y. First off, that's what I do first. I always take care of the GCF first. And now I end up with x squared left because the 5 and the y cancel, minus 3x because 15 divided by 5 is 3, and the y's cancel, minus, now I have 140 divided by 5, which is 28. The y's cancel. Just a moment, please. Just a moment, please. Wait just a second, please. Okay, and then I have to take care of this middle part right here. So I've got to factor this trinomial. So I have the b equals negative 3 and my c equals negative 28. So now I have to think about my factors for negative 28. It might be around 3. And it's got to be a negative 3. So it's going to be 4 times negative 7, which when I add that together, that equals negative 3. So I'm now going to have 5y, open parentheses, x plus 4, close parentheses, x minus 7. And this is my final factored form. Again, if you have questions, you can rewind or you can ask me. Have a great day.